A shape memory polymer can memorize a temporary shape and can recover to its original shape upon application of an external stimulus, typically heat. So shape memory polymers have many emerging applications, and these include industrial applications and also emerging biomedical applications. Our materials consist of a polymer network, so an elastic polymer network, and attached to this network there are hydrogen bonding groups. These are dynamic hydrogen bonding groups, so there is no one well-defined temperature that determines the behavior of the shape memory material. So we're using a different mechanism, a different approach to creating shape memory material. And the material from our lab is also unique because once it is cooled, the rate that the material recovers or returns to its original shape can be controlled. And it can be controlled by changing the composition of the material and also by choosing a different temperature. So the material recovers slowly at low temperatures and exponentially faster at high temperatures. The ability to control the rate of shape recovery could be very important for certain applications that we've envisioned, especially biomedical applications where a practitioner will want to deform the material, insert it into the body, for example an implant, and have time to carefully adjust the material so that it is installed correctly in the right position. They don't want to have a material that prematurely recovers in an awkward state. The surgeon needs control and needs time to position the material correctly. An additional advantage of our material is once it's cooled into the low temperature state, it has properties that are not unlike an elastomer. It's still a soft material, and it can be manipulated. And our material at 40 degrees Celsius, 37 degrees Celsius, the body temperature, has a fairly slow recovery rate, and that's an advantage of our material. The surgeon has enough time to go in and position the implant correctly and orient it correctly such that it's in the optimal configuration. And we're also looking at ways to use photochemistry to help us fabricate the shape memory polymer in different shapes, in elaborate shapes. So the University of Rochester has intellectual property on the core technology of using hydrogen bonds to create shape memory materials. But we are currently expanding our portfolio to cover different applications that derive from the core technology. And we realize that it really is a versatile technology that can be amenable to many, many different applications.